So we continue discussion about the OpenPOWER enterprise, and if you've been to our previous session, I told that in the OpenBMC we've had quite a lot of identified quite a lot of enhancement requests or whatever need for changes. So when our server platform was almost ready, we decided that we need to compile that list of features that we want to implement and get to the customers and ask them what priorities for these features they would like to have, because, well, we want to do many things, but there's not enough time, like always. So, so we approached our couple of our big enterprise customers and asked them. So that's the features that we can do for you, and do you think is it good or not, and what priorities do you want to have, and in what order? And maybe you have any other ideas, and there was a very interesting discussion around that. These are really large enterprise customers who used to deploy many different systems, from the high-end like IBM P series, Oracle Spark servers, huge EMC, Hitachi storage systems, etc., etc. And at the same time, we needed to involve in that discussion the people who are normally managing the Linux servers, because we are targeting this market, and that's why we wanted to talk to these guys as well. And they are, of course, they are mainly experienced with the x86 systems provided by well-known vendors like HPE, Dell, and so on, Lenovo. And that's why the discussion was very interesting, because the high-end people, they've been talking about high-end features, and the x86 people been talking about the what they used to see in the Intel world. So so here is the list that features that we've got. As I said, some of them are implemented in our hardware, some of them are in progress, and a couple of points here are customer requests, and we also sort of managed to resolve them, you will see. NMI. Well, the term is not correct, of course, for OpenPOWER, because we all know that NMI is a non-maskable interrupt. It was implemented by IBM and Intel in the early days of x86 era, and initially it was intended to just to give user ability to reset the hung server. Well, we all know. The term is not correct. In Power specification, this is called something like a system reset. But when we are talking to the x86 people, we have to use this term because they speak this language, and yeah. So in all our internal notes, we refer it as NMI. Funny. At first, it appeared that this kind of feature was not even designed and implemented in the Power 8, because our server is based on the Power 8. Not in the system firmware, not in the OpenBMC as well. And but the customer said this is a top priority and a must-have feature for for the enterprise environment, because in case if system is not responsive or maybe, well, seems like hung, you need to do a reset and collect the kernel dump and send it to support to kind of diagnose it and see what's happening inside. So later on, after some additional research and with the kind help from IBM engineering, we found a couple lines of commented code that has to be uncommented. It didn't work. It has to include some other changes as well. And finally, we implemented in OPAL, in OpenBMC as well. And now our server is doing the system reset like it should. And involves a Linux kernel dump component. It appears that Linux should run a rather fresh kernel version, and it supports only starting from 4.14 and later on. Not all operating systems yet transition to that kernel version. For example, the Red Hat, I think only the beta preview of 7.7 is now able to run 4.14. Well, not able to run, but I mean includes the 4.14 as an option. But earlier Red Hat releases did not support that kernel, and we are waiting for Red Hat to catch up on this. Ubuntu works well. Interesting is that now we learned that IBM is also IBM and the OpenPOWER community are also working on porting the firmware-assisted dump into the OpenPOWER from the P series, and this will be interesting to see how it develops, because it will increase the enterprise capabilities of the platform and it will be good for everybody. So now we are going to the audit of user activities in enterprise environment. It is very important to know who is doing what and at what time. This, first of all, this is required for like troubleshooting, because, well, something has changed something, and, well, after that, nothing is working, and who is guilty. And another reason is compliance, because for security purposes, the financial institutions, for example, they have to keep the track of all the user actions and things like that. So that's a very important feature, and we've already developed this as a logging and display of the user activities as an audit dump. Here is the sample output. It was taken from the early release because you can see that it doesn't include the IP address of the associated user, which is very important. In the final release, which is going like I think at the end of September, very soon, this output will also include the IP addresses, and so you can see the date, the timestamp of the action, the interface it is coming from, like IPMI, CLI, or REST. The digit column next is the exit code, so 0 success, and then 2 create dump. By the way, that was a test of the feature of the system reset, and it didn't succeed because the operating system is not yet running. So you see that the host call reset was done just a few minutes ago, so the OS is not yet booted. But anyway, it shows you that some action was successful, another action was not successful, etc., etc., and the action itself. So like host reset and user root, logged in, and things like that. Very useful. Yes. Yep. It's in the OpenBMC, yeah, on GitHub. Probably in our fork, maybe not in the main code. Well, I'm in doubt. I can't tell actually. So from what I know, that this will also probably be implemented in some other way, and later on you will see why. So right now we needed a kind of a quick solution for our own purposes, and later on it will be probably in the third version of OpenBMC, it will be implemented in a bigger extent.
Yeah, we're also working on that, so I was wondering if you already did it. But you did a quick and dirty solution, and you
something like that. Yep. Quick and dirty, but good solution. Now that's was another interesting feature. Well, the system takes some time to get through the self-test. For example, our server takes like 10 minutes to get up to the operating system, or at least the Petitboot. And the users already want to change the boot device entries. We are sort of halfway in implementing this, because the first phase that we've done is we can do switching between the generic disk network and removable devices, and the second phase that we are working right now and will be available, like I think in November or October. That's even you can tell a specific UUID of a boot device that you want to boot. Interesting enough is that this feature was also requested not only by our customers, but also by our own internal storage development team, who is working, the guys who are working on the storage controller solution. So you see, I'm not a developer. I help them. So I help them to do the design, what is required. Then I do the tests and things like that. But I'm not a developer, so I can't tell you exactly where and what they did code. So I think this is also, yeah, this should be available everywhere. So yeah, I hope so. Well, our idea is not to develop only our own product, but also to help everybody to develop the entire line of products. The entire community should benefit. Access to the video console over LAN. So the thing is, again, it is already supported in the latest generation of BMC hardware. But in the generation that we have in our platform, it was never implemented and never even planned to be implemented. The discussion around this topic, so this request came from the x86 guys. They say that they really need it, and we didn't, for a long time, we could not understand why. And at the same time, the high-end team say that this request is ridiculous and it was never implemented in the high-end systems, and well, forget about it. But later on we understood so that the x86 guys, if the system is dead, is doing a kernel panic and power off, they at least can attach a video terminal and see what are the last words said by the host when it was dead. But luckily, the OpenBMC has a console log file, and we just, when we understood the reason, we just say, oh, come on guys, that's not difficult. You can just have a look at that file, and they say, oh, now we are happy. So we are resolved this request. Now this came from the high-end guys. the BMC card, they say, if it's a single point of failure, that's bad. Well, okay, we say, okay, it's a high-end feature and we are not doing a fault tolerant system. Some components in our system are single points of failure. We are very sorry, but this is the market we are working on, that our system is a 2-unit Linux box. You will never find a similar computer from anybody else that will have some redundant BMC ILO or drag card. Well, at least we convinced them that this is not necessary to be done in our hardware. And interesting is that as I said in the previous session, the CPUs and memory are the single points of failure, but we float the high availability features to the operating system, like to the clustering software, to data replication, and things like that. So, but we also know that OpenPOWER community is working on a live CPU core deconfiguration and live memory deconfiguration features, and not only deconfiguration but also configuration. And this will greatly increase the enterprise score of the OpenPOWER platform. It will be great to see the development in this area.
Also, that is on the redundancy is on our roadmap, but it's quite a ways out.
Oh.
So we are intending to do a redundant design.
Okay. I think this will probably be useful for the big systems where, you know, because I know that P-series will sooner or later migrate to OpenBMC as well, right? So if you have a big box, like a one rack. Yeah.
You can tell your customers that will be coming, but just it's the last thing we're going to put on.
Yeah. But not for the small systems, of course.
Not the small systems.
Not intended to be that way. Not expected. Okay, and now this is a little bit in relation with the audit log. So we understood that the users, they need to have at least one more user account, read-only. For example, the use case is like the night shift, duty shift. So people who don't very well know the system, but they could be required to access the system and at least read some logs and read some, sensor values and things like that, and access the console to get to the host. But they definitely don't have to change anything in the system. Right now, OpenBMC has only two built-in users, is a root and admin. And root is like it's our engineering user. We don't give access to our customers with the root access. And then they are left with the only one account. It's an admin with the simplified CLI. Well, it essentially can do anything, like reboot a host and whatever. So now phase one is that we will develop a read-only user, and the phase two is a full-featured role-based access control with a enterprise directory integration. I think it is in progress in the OpenBMC community, and we are sort of waiting for that feature to appear, and this will greatly improve the OpenBMC functionality.
That is in progress, right?
Yep. Now, this feature also is in development. Until the Petitboot is able to load the bootable images from network locations, like for FTP, from HTTP. The x86 people are used to occasionally boot from a file or a folder image which is stored right on the workstation where the operating is working. This is very often happens in the scenarios like when they have to do a firmware or software update or like a troubleshooting, diagnostics and recovery and things like that. In many of these situations, the maintenance window is very short and the time is running very fast. And it's difficult to fit in that time so that for the user to upload the image to some FTP location and then fiddle with the long URL to put it in the Petitboot and so that the system can boot out of there. It will be much more easy, like when on a web browser, user can click the open image and just upload it from their own computer workstation, and the system will boot out of there. Very straightforward process. So we know that this feature is being developed in the OpenBMC project, and which means that this enterprise requirement is clearly understood by the community, and that's great. Good. So yeah. Now I see that. Yeah, you probably know more than me on this entire topic. Yes, that's a clear request. They say that's a very good. They don't say that's a top priority, because really they say the top priority was the NMI that we've done. Yeah, and that already exists and working on the Power 9 as well. Power NMI again. So yeah. Now call home. So enterprise solutions are impossible to imagine without 24/7 support, and the call home feature has always been an important part of that process. We are currently developing the call home solution that will be available for our server platform and also for our storage process. That will be a unified solution for all our product lines. It should include the OpenBMC embedded agent that will sort of upload the log files if required, or at least tell that everything is okay. So like send a heartbeat. It will. We're also thinking we need to develop the host operating system based module, the agent, because not everything is available from the BMC in the system, like PCI devices and VME devices are not visible on a BMC level, and their health is also required to be reported to the call center. And the most important is that we also thinking to develop the intelligent backend data processing system that will be able to timely process the failure logs and the regular telemetry uploads, and it will integrate into the customer support service desk and the install-based tracking systems, so that all the information will be like collected and stored in the appropriate places.
We actually have a solution for that right now.
Right now, so I've seen in the development plan for like the year of 20. No, the call home.
Are you going to be here tomorrow?
Huh?
Are you staying?
Yes.
So I'm giving a talk on that at the end of the day. Part of it is how we're getting this data off of the BMCs and streaming this telemetry data out for analysis.
Great. Only the telemetry. What about the error logs?
Yeah. Yes. So there you can get alerts. We're working on the full system where you're going to have the error logs and everything is going to be passed back. That's not there yet. Where you can call home the error logs. That's in the works. But what we have right now is telemetry data and you can get alerts for when certain things would change. Like if you want to set like a temperature trip point or something, you could set that and then it would, and then you could get that. But we should maybe talk offline further about.
Okay, thank
Yeah.
you, thank you. And the dream is to develop a mass monitoring management and deployment tool. The imagine is that if you have quite a number of systems installed in your data center, there's a short maintenance window when some of them, maybe not even all of them, but some of them are available to perform a firmware update because it is rolling out. What if you need to boot a number of systems from the same network image, or maybe change like some common BMC settings on a set of systems, like maybe NTP or SNMP configuration or whatever. So something that is not unique to a single BMC, but like should be across the set of BMCs. Well, it's clear that OpenPOWER systems should have this kind of tool that will help to do some maintenance tasks in parallel. This tool could also perform basic inventory and monitoring of the systems, like for a customer, not like a call home solution that will report this data to a vendor, to a hardware vendor, but for a customer, so that systems are good, you know, the green, the fans are rotating, the power is okay, and the temperature is good, and maybe allow some third-party products integration, maybe even like Nagios or Patrol or Tivoli, who knows. We probably will initiate this project later this year, and it will require significant resources and effort, but it should be getting up to speed because, well, that will be a good tool for.
So you could use have you heard of XCAT?
Pardon?
Have you heard of the software called XCAT? It's open source. I don't know if it does everything you want, but.
Well, yes. Well, we understand that there is a number of solutions that can do that work, but we either that's a good idea. So probably we think that we may take one of these open source solutions, but we need to at least to deploy the templates and these scripts, how do you call that, the receipts, the receipts for the for these tasks.
I don't know what you mean, but what we have it. I mean, this works at our big national labs at scale, right? So we've got XCAT running with all kinds of our P9s with running OpenBMC, and it does your code update and monitoring and everything. So it's already working.
So is it even you can do a firmware update?
Firmware update, yep.
Really?
Yeah.
Interesting.
So, I can send you some pointers to that.
Well, at least this is something that we should develop, not the customer, because, well, actually the customer can do it themselves, right? But enterprise customers are not doing that kind of stuff because they don't want to take this responsibility. What happens if something goes wrong and the firmware update will fail? Yeah.
Right. Yeah.
And what if this happens on a dozen of systems at the same time? That's a total failure.
Right. If you're going to sell like a cluster, I mean, you would definitely have to sell the software that manages that cluster, or include that, which is what you can use XCAT to.
And not even as a cluster, because customer might have a number of clusters, right?
Yes.
But we just sold it not as a cluster, but just as a bunch of servers, like rack mount servers. Yeah.
Yeah. Okay.
That's the idea behind. Yeah. Sure. Yeah. So that's it. So that was a list of enterprise features, and as you already noticed, it's good that we've done it in cooperation with customers, so that we are not just talking like from ourselves. We know that we are not alone on this track, so we rely on the OpenBMC community and OpenPOWER community as well, and we hope that sooner or later we'll make it the major ecosystem around the OpenBMC and the OpenPOWER servers. Thank you.